Hi everyone, welcome to my channel. I am Dr. Shabazz. In this video, I will demonstrate how to conduct and interpret the Friedman test in SPSS. The Friedman test is a non-parametric statistical test used to compare three or more related measures. So we also did the same in ANOVA with repeated measures and with the post-hoc test. So we will also do post-hoc test in this Friedman test in SPSS, and this is a non-parametric test. So we have an example of data set. We have 30 employees, and we will check the digital confidence of employees at baseline, immediately after training, and confidence after 1 month. So we will check the confidence of employees at baseline, immediately after training, and after 1 month. And we may ordinal scales 1 to 7. 1 equal to very low, 2 equal to low, slightly low, moderate, slightly high, high, and very high. Okay, so now we go to good data view and you can see our data set. So in this way, our objective is to determine whether digital confidence changed significantly across these three measurement occasions or not. So after performing the Friedman test, we will use Wilcoxon sign drag test as post-hoc comparison to identify which measurement occasions differ from others. So we will also calculate Kendall W and the overall size effect and apply a Bonferroni correction to the post-hoc comparison. So we will calculate both Kendall W technique and Bonferroni correction to the post-hoc comparison. Okay, so first of all we do the Friedman test in SPSS. So we go to analyze, then click on non-parametric test, and then click legacy dialog and go to K related samples. And you will put all the observations sequentially. So the first one is baseline. So we will put the baseline first, then confidence, post confidence immediately after training. So immediately after training, and confidence after 1 month. So we click on statistics and we need descriptive statistics and click on OK. So we get the results of Friedman test here. So in this test, you can see the sample for each 30 total sample size, and you can see the descriptive statistics show that a consistent increase in confidence, like you can see the mean value for digital confidence at baseline is 3.57 and then 4.57 immediately after training and then 5.43 after 1 month. So you can see the confidence is increasing after first observation and second observation. And on the other hand, you can say that this is the most important table, ranks with Friedman test. You can see the mean rank at digital confidence at baseline is 1.15 and mean rank at confidence immediately after training is 1.95 and confidence after 1 month is 2.95. So you can also see that the mean ranks followed the same pattern. The mean rank was 1.15 at baseline, 1.95 immediately after training, and 2.90 after 1 month. So this indicates that confidence was lowest at baseline and highest at after 1 month. So it means it is increasing significantly. So on the other hand, we see the test statistics chi-square value is 49.784 and the p-value is 0.000, which is lower than 0.05. So the Friedman test revealed a statistically significant difference in confidence across the three observations. Because the chi-square value of 2 equals to 49.784 and p-value is less than 0.05. So therefore we reject the null hypothesis and conclude that digital confidence change significantly over time. So after the Friedman test, we calculate the Kendall W to check the effect size. So we go to our presentation and see how to calculate Kendall W. So basically Kendall W will be calculated by chi-square value. We will put the chi-square value like 49.78 we generate from the results. You can see 49.78 and divided by 30 total observations, multiply bracket 3 number of observations. So there are 3 observations baseline, immediately after training and after 1 month minus 1. So we get the Kendall W 0.83, which shows a large improvement. So because the value is 0.83 is larger than 0.50, so there is a very large improvement from baseline to after 1 month. Okay, so we also see the other things like omnibus alpha 0.05 and the p-value should be less than this alpha value, and the pair count, and the most important thing is Bonferroni adjusted significant level, which will be calculated by dividing the significant level 0.05 divided by 3, and we get the Bonferroni adjusted significance level 0.0167. So we will also compare whether the value of our test is lower than Bonferroni adjusted significance level and the significance level. So in both cases the value is lower. So in this way we can simply say that there is a significant improvement from baseline to after 1 month. Okay, so we also see the Kendall as I have explained you that we calculated the effect 0.83, so which is larger effect size and which shows a very large improvement from baseline to after month. So now we will do the post-hoc test using Wilcoxon signed rank test to compare the baseline with immediately after training and with immediately after training with after month, and as well we will also compare baseline with 1 month. So we will go to analyze and then click on non-parametric test, then click on legacy dialog and then two related samples. So in this way, first we will put the sequence of observation, like first one is digital confidence at baseline. We will put variable 1, and now confidence immediately after training 2. Options descriptive, continue, and then OK. So you can see the descriptive statistic, the mean value at baseline is 3.57 and immediately after training is 4.57. So you can see confidence increased significantly from baseline to immediately after training. And as well, you can refer the Wilcoxon signed rank test and see the ranks in this table, where we can find that 25 positive ranks and negative ranks 2 and positive ranks 2. It means 25 participants reported higher confidence and only 2 reported lower confidence and 3 reported no change. So we also see the test statistics, z-value and the p-value 0.000. So in this case, we will also calculate Kendall W by dividing minus 4.255 and we will use the same formula and we will calculate the Kendall W to see the effect, like effect was small, moderate or large. So we calculated the value as for Kendall 0.78, so which is also greater than this value. So there will also a very large improvement from baseline to immediately after training. So now we check the next post-hoc test. We will go to analyze and then click on legacy dialog box to related sample. So first we compare at baseline to immediately after training. So now we will compare at baseline to after month. This one. Okay. So you can see also here the mean value at baseline is 3.57 and confidence after 1 month mean value is 5.4. So this is also increasing from baseline to after 1 month. So we see the Wilcoxon side rank test ranks. So you can see here 28 participants reported higher change and higher improvement, 0 reported decline and 2 reported no change. So we can also see the test statistics here. The p-value is 0.000, which is lower than 0.05 significance level. So we also here reject the null hypothesis and accept the alternative hypothesis because there is a significant improvement from baseline to after 1 month. So in this way we also calculate the Kendall W by using this formula. So we calculated and found that there was 0.87, so which is also higher than this value. So we can simply say that there was also a very large improvement from baseline to after 1 month. Okay, now we move to third post hoc. Click on analyze, then click on legacy dialog and to related sample. So now we will compare immediately after training to with after month. Okay, so we get the results. So you can see mean in immediately after training is 4.57 and after 1 month 5.43. So there is also a significant improvement from immediately after training to after month. So confidence increased significantly between immediately after training and the 1 month because the z equals negative minus 5.099. And we can also say that 26 participants reported higher confidence after 1 month. No participants showed a decline and 4 participants showed no change, mean no improvement. And you can also see that the p-value is 0.000, which is lower than 0.05. So here we also reject the null hypothesis and we accept the alternative because there is a significant improvement from confidence after 1 month confidence immediately after training to confidence after 1 month. So there is also a significant improvement. So if we conclude the overall results in one line, we can say that digital confidence increased significantly from baseline to immediately after training, and immediately after training to after 1 month. Confidence was lowest at baseline, higher immediately after training, and highest after 1 month. So we can also see 1 month by applying the Bonferroni technique. So if we divide the 0.05 significance level by 3, we get this value 0.0167. So the value of P is also lower than this value. You can see from our results that the P value is also lower, this one and this one and this one. So in all cases the P value is lower than Bonferroni adjusted significance level. So in this way we can simply say that there is a statistical significant and very large improvements across all these measurement occasions. So these findings provide strong evidence that the training was associated with the substantial and sustained improvement in participant mean implies digital confidence. So in this way we conducted Friedman test using post-hoc test with different levels. So if you find my video helpful, please subscribe to my channel and press bell icon so you can get my new videos. Thank you.